We're going to go ahead and get this guy flipped over and set back up here. Just want to make sure all the chips are clear. I think we are ready to go. Plenty to clean on this side as well, though. Now I just remembered that before I set the plate on here, I need to Z off of this surface right here. That's how we have our setup for op 2 is coming off of this face up to the bottom of the plate. So we'll do that first before we set it on there. We'll do a single surface for our Z location. All right, there we go. Yep, wrong axis right there. We need Z up. Yep. I'm going to take my probe out of here, and then so once we set the plate on here, we'll have to get it trammed in nice, and then we'll use our 1/2-inch hole and we'll reprobe it XY center on that hole. All right, we'll just use our scale measurements again and equalize it. Roughly 2 inches. That's pretty close end to end there. Pretty close. So again, we're not going through, so it's really not super critical that we're centered, but I want it centered there. All right, and then we'll go side to side. Got 1 1/8 inches. So it definitely needs to go that way just a little bit. So that's real close right there. This one's got to come this way. Oh. Oh, that's close right there. Yeah. All right, I think that's going to be close enough. And we'll use our same technique with our surface gauge and our dial indicator to get this dialed in nice and straight. That's the most important on this setup, is that we need one of these sides nice and straight, and then we'll have to probe the center of this hole. All right, going back in with our surface gauge and 196 indicator. Tell you what, let's start down here on this end. Now let's see how close we have it with our scale measurement. All right, so we got a 0 there. 1/1000ths in the center. Total of 4/1000ths shallow on this end right there. All right, so that's 1 over the 0. And then -4. So we were then 5/1000ths just eyeballing it with our rule on there. Not bad at all. This is going to be a little tricky to bump. And very gentle bumps is all it's going to take for this, and then we can mag it down. So that's -2. And that's -2. I'm kind of splitting tenths here. That is actually really close right there. I'd say within maybe 2 to 3 tenths being trammed, just that little bit right there. So that is good. I'm gonna leave it right there. Go ahead and grab my wrench. And let's go ahead and mag this guy down so we know we don't move it. There we go. Okay. Give it one more check here. -2, -2 and a few tenths. I think that's close enough. I'm real happy with that. That looks good. Go back in with our probe, and we'll walk it in here to our hole location. This is where you got to be careful. You make sure you're in the correct axis before you start moving it. And I want to just kind of eyeball that hole there. Yep, it's a little bit forward. Something like that right there. And now we'll drop it down into the hole. About like that. I'm going to slow my rapid way down, and then we'll get a probe operation set up. Okay, XY is in our 0 there, so we're gonna, again, gently, I'm looking to be sure that we're in Z, and we're gonna take it up nice and gentle. All it takes is just breaking one of these things for it to slow you down and make you pay attention a little bit more on protecting these very expensive tools like that. So for me, I just try to take my time now because it was a mistake that I made that I learned from. All right, so we are now set up. And so again, we're gonna face it off, 1/32 of an inch, and then a chamfering tool, it'll chamfer all the holes and bevel the outside, and then that'll wrap this up. Okay, we're ready to start making some chips now. I'm gonna handle this just like we did the first side. I'm gonna bring everything down nice and slow and be sure that we are in our correct location before it starts cutting chips. Cooling off. Let it get down to its 0 location. All right, 0.9375, that's exactly where we want our thickness there. That should be good. Turn our coolant back on and let her feed. I am running the coolant on this because I have found that it does make a difference on your surface finish. I know a lot of folks don't run coolant with face mills, and you can certainly run them dry. We do it all the time. A lot of people do it all the time. But I just think that the coolant helps the surface finish in the end there. It's going to make it a little bit more shiny and just a little better job altogether. All right. It's time for the tool change here. I'm going to go ahead and take a look at the surface finish. Looks nice to me. Yep, that looks good. Nice finish on there. All right, we'll do our tool change to tool number 39. I believe I already put that one down here in the cabinet. We've got our counterbores to do now. Half-inch end mill. Okay, tool reset, cycle start. Turn our coolant off. Bring it down nice and slow, make sure we're in the right location. It looks right. Yep, that looks good. Turn our coolant back on. Clean up, spring pass. Okay. All right, tool change number 40. This should be our last tool. Chamfer. Coolant's good right there. Tool reset. Again, we're just bringing it down nice and gentle. Okay, that looks good. Doing a 10 thousandths edge break on all the edges. End of the line right there. That should be good. Jog the spindle up and bring our plate to us. Yeah. That looks nice. Looks really good. All right, so the only thing that I do not have with me to complete this job is, well, I need the proper length dowel pins, and I also need these 14mm bolts. So what I'm gonna do right now is I'm gonna head down the road here to my local threaded store that I shop at, National Standard Parts. They have 14mm socket head bolts in stock. I'm gonna go ahead and grab some of those for this job. I'm sorry, not 14mm. I keep calling them 14mm. I don't know why I'm getting that. But anyway, 10mm socket head bolts for both sides here. And then we'll check to make sure that the counterbore is correct. We use the fusion file for standard sizing for those socket head bolts, so they should fit in there. But I have to make sure that these are sunk down below the surface, because this is our actual mounting surface that's going to be upside down there. So I'm going to run and pick these bolts up. I'm going to run by the home shop, try to find me some more dowel pins. I think I got some in my rotary bin. Grab me a sandwich for some lunch, and then we'll come back and we'll check these, and if we need to modify those, we can do that as well. I just got back with our 10mm bolts. They'll go in there just like so. And it looks like the design right out of Fusion is correct. If I put my scale across there, it does not interfere with the bottom bolt. Looks like it's got about somewhere between 5 and 10 thou clearance in there. So that's going to work good. So we got our bolts now, and this is finished up. So I went by the home shop to grab a couple more of these 1/2-inch dowel pins. This is the only length that I have, so I'm just going to use the grinder and a cutoff wheel and cut a couple of these to the length that I want, rebevel one in, and I'll just use the pins that I have here. Before I take it out of here, I wanted to get a measurement and see how consistent on the thickness that we were. So our target dimension was 0.9375, 15/16. We just took, we touched off our material, took a 30-second off one side. When we flipped it over, it took the other 30-second off of there. And let's see where we finished up at. I'd like to see how parallel both surfaces are. We'll just start with this corner here. All right, so that's 935 and 2/10 on this corner. That is also, that one is on 935 right there. All right, 935. 5/10 on this back corner. And this one, (935) and 2/10 on this one right there. So I'm actually really pleased with that. We are less than 1/2 thousandths of being parallel on this plate right there. I'm going to contribute that to our mag vices there, helping us maintain a nice flatness. Even when I'm using my regular milling vices, and I've done some plate mill on here, I have gotten some variation in thickness, 1, even up to 2 thousandths before. So I felt confident that decking off these two mag vices and sucking it down like we did should have held it nice and flat and not have any worry about if there was any kind of warp in it, pulling it down and causing some out of flatness once you release the mags and it's springing back. So less than 1/2 thousandths parallel in our part right there. I'm quite happy with that. So let's go ahead and unmag it and get it out of there now. Move this guy down. Come on, you gonna let go of it? make sure I've got it unlocked. It might be just, sometimes you still have a little bit in there. Yep, it's just stuck. It's just stuck is all. There we go. All right. All right, we'll get the 4th axis out of here and go to the table and test fit everything. We'll set our plate down here and double check our hole pattern as well, but it should be good. I don't know how common it is for other makes of machines not having easy access to put the 4th axis on here, but I saw some guys on Instagram complaining about the way that the machine is built with the covers up here. They can't get their 4th axis on like I can right here. They're having to like reach in and set it down. But I just wanted to point out with the VM from Milltronics, you can see it's not an issue. They've got it designed. I like how they've got this little cutout right here, perfect for the strap. So you can take your 4th axis and be able to set it right down on the table. So let's go ahead and make sure that our plate does mount up to the fixture here, and then we'll take it and we'll set the 4th axis down on it. So it should match up on the total length there, and it'll be even with the side of the fixture plate. It looks like it's mounted up just like it's designed to. So let me get some of our bolts. Okay, looks nice and even all the way around the fixture there. So I know our mounting holes are lined up, and our dowel holes, they look like they're lined up as well. So hopefully they're going to fit right in there. And by the way, let me grab one of these dowel pins, and I'll show you the way that Saunders has this fixture plate design. They have a counter bore of a 1/2 inch, and you can see these standard 1/2 inch dowel pins fit in there really nice. So I haven't measured it. They probably got them, you know, 1/2 to 1/1000 over, but that is a really nice fit on a dowel pin right there. So that's handy for any of your fixtures that you're going to just set in here and line up, or you can use that to create a fence to, you know, a stop to push work pieces against. But we'll have 2 here and here that should line up and fix this, so that every time we go to set this thing on there, it's just automatically aligned nice and square to the axis of the table there. So I do want to pull this out. We're going to go back to the table to set our 4th axis down to see how it fits with our keys. And then of course we can begin bolting it up. We've got these 2 will have to bolt from the bottom, and then these 2 bolt from the top there. We'll go ahead and set the 4th down here on the plate. See if it fits like it's supposed to and the holes line up, and if it does, we know we're good to go. we'll coat it down really well with the SP350 before we do our final assembly on it. There it is. Yes, sir. It's fitting like it's supposed to. We got some of our 10mm bolts here. It's a little tight going in. It's fitting though. A little bit tight. That went in. I got 30mm length bolts. It looks like I might have needed to get 35s. I think this is going to work though. Those do have washers underneath them there as well. Those are some AN style washers. Okay, well let me see if I can lay it down. This table's going to try to roll on me. Okay, and we got our 2 bolt holes right there. It is a little bit tight. I'm going to go ahead and loosen up these 2 bolts here. I don't know if that'll give it some room, but we'll just see if they want to screw in. It's trying to, but it looks like it's right against the edge. See, that one's going in. There it goes. I think the plate, it was just shifted a little bit. That's all it was. Well, that makes me happy, and I'm, you know, a sigh of relief that everything is fitting like it's supposed to. And one of the things I'm learning is the beauty of working with 3D models or solid models in Fusion there. Taking pieces that already have all of the dimensions on there, just transfer it to the part that you're working on. That is awesome. So hopefully the last thing that we don't know if it's going to fit is the pin locations, but hopefully that's going to go well. And so I'm going to go ahead and take this back apart, and I have the pins cut. We're going to go to the home shot. I got the hydraulic presses there, and we're going to use that to press our 2 pins in, and we'll do that, and then we'll try our final fit. Okay, we are set up on the Dake hydraulic press. I went ahead and I cut our pins to the length that I wanted, chamfered and dressed the ends, but the factory bevel end is the one that we're going to be going into like that, just like so. But I am going to put some of the anti-seize on both of them before going in there. I'm just going to use a little bit on this acid brush. Makes for a little bit of a cleaner job. Way more than we need. That'll be okay. Just trying to prevent any kind of galling that might happen as we get these guys pressed in there. All right, let's get one going. Okay, let's start pushing on it. It should straighten itself up, hopefully. All right, there it goes. I'm gonna back off. You can see it moving a little bit because the I-beams or the channel iron on the press isn't exactly nice and flat. It's going right in there. And then What I was going to use is a little scale like this to kind of gauge our depth. I wanted a 1/4 inch. All right, so something like that right there. There we go. It looks pretty good. I'll just pull it out here and take a little measurement with it. Yep, so that should be good right there. We're just past the 1/4 inch. Those counter bores I measured them being about 265. So that being right at 1/4 inch, that should line up and not hit the bottom down there where the threads are. Okay, we'll get this guy flipped around to the other side. I was trying not to do that. I'm trying to prevent any kind of scratches on the surface the best that I can. That looks good, just below the 1/4 inch line. All right, I think that job is done. Turned out well, looks good. Okay, we made it back to our Milltronics. I'm gonna do a test fit and see if the plate lines up. Now I'm not gonna go on to the location that this is gonna sit at because I have no good way of getting it off unless I use a magnet or something because it's absolutely flush with the side of the fixture. So we'll just kind of move it off so that it's overhanging this side of the plate and just see if our dowels line up with these holes here. Okay, here you go. I think what we'll do is we'll just line up with this, the very last hole here, this row here. Look at that. Like it was made for it. Man, you just, when a plan comes together, you can't help but smile. I mean, I'm smiling. This is good stuff right here. This is awesome. Man. I cannot believe how nice of a fit those, you know, commercially available dowel pins fit these holes right there. I can tell that, you know, Saunders has done their homework a long time ago because they've been making these for years now on having factory made pins fit these holes. So our plate, we know that it's going to fit in there because the center distance is proper and these were all on the exact same hole pattern. So we're good to go. I'm going to see if I can, let's see if I can pick it up and get it out of here now. See, that's another story, getting it out. There we go. Okay. All right, it's time to get all this put together. I'm ready to get it on the machine. Okay, I'm ready to get this fully together and get it on the machine. So we're gonna go ahead and coat everything really nicely down with the SP350, a corrosion inhibitor and a lubricant. Go ahead and clean the bottom of our 4th axis again one more time. We'll see if that'll hold it together so we can lay it back and get the other 2 bolts on. That should be good. That should be good. We're going to go ahead and stand it back up. Tighten those other 2. All right. Time to go to the machine with it. Give the machine one more clean here. And then coat it down with our SP350 also. Now, one thing I anticipated was that because of our fixture plate here, we are going to have to kind of push it a little bit, and hopefully those 2 pins are going to align, because the way they had this engineered was you could set it straight down onto the T-slot table, but we're having to take it further back just the way we designed it. So let's go for it. There it goes. There it goes. Now it's on there. Well, there it is, fully mounted up in the machine, minus the cables, of course, but we do have it mounted, and I am extremely happy with the outcome of this. I'm really, really happy with how well the subplate was machined. Our TRM did a fantastic job. Our designing went just as we had designed it to fit together. It was awesome being able to use our solid model of the 4th, solid model of the fixture, and see all 3 pieces actually go together in the software before you ever even machined anything, knowing that these hole locations are going to match up just as they were designed to be. I'm just very excited about this. This has been a great project, and I'm excited to see this because we have Milltronics coming down next week, and I'm hoping that we're not going to be, we still don't have any work holding for our 4th axis, so that's the next step. I need to get a chuck on here, I need to get a vise. This is all stuff that I'm learning about, but what they'll be able to do is work with me, and I'll be able to see how this is used with our software whenever we're going to be, you know, machining a part for 4th axis there. So I believe that is going to be a wrap on this particular project. I have no idea how long the video is at this point, but we've been working on this, and I had a lot of fun sharing the journey of this one and everything that we used to create this, you know, using our Fusion to create a part. Kevin did a fantastic job helping me and showing me and teaching me how to use solid models to aid in your design, and that all worked out just as planned. And the TRM did a fantastic job machining our subplate. So it fit in there just like it was supposed to, and I'm real happy with it. So I think I'm gonna call it. That's about it for this particular video. Of course, we're gonna have a lot more content to share on the new machine, and as we start learning how to operate it, it's gonna be very similar to the TRM over there, but we have some new benefits, you know, for this machine. We have a new controller. It's very similar, but it's just an upgrade. So there's some new features on the controller that I need to learn how to operate. We have a new pendant right here. We now have a 4th axis capability. We have a swing arm tool chains on there. We have more tools. We can hold 24 tools, and we have coolant through spindle. So that's a really nice upgrade, being able to invest in more of our coolant through cutters, drills, and end mills, and all those kinds of things that we can benefit from the high pressure pump with our through spindle coolant there. So I actually do have a project already lined up for the 4th axis. This is some that came down the pipeline a few months ago, but they weren't in any hurry for it. It's sort of a long-term project, and the type of project that it is, I think it would be well suited for doing in the 4th axis right here. So that's something that's going to be the first job that I'd like to do using the 4th axis, but we'll get to that later. I need to get a chuck for it and get some work holding and get a little bit of training under my belt so we can hopefully be able to put this guy to work. All right, so that's it. Again, I'm really excited. You can see the smile on my face on how well that subplate fit in on our fixture plate there. I hope you guys enjoyed the video, and I hope to see you back here on the next project, all right?